Okay, so in the previous video you saw how we factorised this. I'll take that off. We factorised this cubic by splitting into its linear factor here and a quadratic factor, and we did it using that equating coefficients method. We worked out this linear factor by doing the factor theorem. I'm going to show you something now called polynomial division. Now it's a little bit tricky. It's not that tricky, but some students find it quite hard, so I'm going to try and set it out with the steps in place so you can see what's going on. Okay? In this case we'll end up with no remainder. But let me show you firstly why it works. We'll do our working over here in a minute. Remember, P of x is equal to D of x times, don't need a bracket there, Q of x. And then plus R of x, but we know there's no remainder in this case because we use the factor theorem. Now if I divide through, that means that Q of x is equal to P of x over D of x. So I'm going to write that out as 2x cubed, so 11x squared minus x minus 30 over x plus 2. If I do that division, I'll get my Q of x, which will be some quadratic. So I need to know now, how do I divide polynomials? What is that process? Well, let me remind you of how you've done division in the past. Down here in orange, actually I'll do it up here and then I'll rub it off. So let's say we had 17 and 2,628. So we're dividing that by 17. Remember, you go through and you start with your first number. How many 17s in 2? None. So we carry on. And we've still got the 2 there, so we look at this 26. How many 17s in 26? There's one 17 in 26. 1 times 17 is 17. We subtract this and we end up with 9. There's a few little nuances and different ways we do this, but this is how I do it. Okay, so we've got 9 as our remainder. And we bring down the 2. How many 17s in 92? Well, I can tell you that 17 times by 5 is 85. So that means there's 5 17s in 92. And the remainder is 7. Bring down the 8. Got an 8 here. How many 17s in 78? Well, there is 5 17s in 85. So there's 4 17s in 78. And 4 times 17 is 68. So we've got a remainder of 10. And that's the best we can do. We can't get another 17 out of just 10. So of course this means that 2,628 is equal to 17 times 154 plus 10. In this case there is a remainder. But there might not be a remainder. But we do have our D of x, our Q of x and our P of x. And then this. We're just looking at it numerically. So I'll just rub this off and then we're going to do the polynomial division using a similar method. Okay, so polynomial division is going to look a bit tricky. I'll write it up like our linear division, and it looks like this. X plus 2, and then 2x cubed plus 11x minus 30. And you're going to think I'm doing a bit of magic here, but what I want to do is set up a little structure down here to show you that it's just a 3-step process repeated until we're done. So let's start with the fact that we are dividing a cubic. So we're going to start with the, that's not how you spell cubic, we're going to start with the cubic term. And then once we've done the cubic term, we'll do the quadratic term, and then we'll do the linear term. And in this case, because we're dividing by linear, we can't divide a constant term by linear, so we'll stop there. And it's a 3-step process. 1, 2, 3. I'll try and summarise what these steps are. I'll just put a little line here. Okay, so the first step, step 1, is to divide by the linear term. So in this case, divide by x. There's my x here. So I'm going to divide this term by x. And how many x's in 2x cubed? Well, I get 2x squared. Hopefully that's not too hard. Okay, as long as that x is a unitary x, it's just a single x, not 7x or something, you can usually avoid fractions as well. So we're divided by x, that's step 1 done. The next step is to get the value we just achieved from that division and multiply it by the whole term here. So that means we now multiply by 2x squared, or whatever it is, okay? So I get 2x cubed, 2x squared times x is 2x cubed, 2x squared times 2 is plus 4x squared, and that should have a squared on it, sorry. There we go. Okay, so that's my step 2 and I've done it now. Step 3 is to do a subtraction and see what my remainder is. So I've accounted for this now in that term. I want to see what's left over. Now these two cancel out to give me 0x cubed, so that's great. Now 11x squared minus 4x squared is 7x squared. So now we're doing a subtraction there. So we subtract, for lack of a better summary, but you are listening. And that's my third step. And to set up for my next line, I bring down my next term, or I can bring down both. I'm going to bring down both. It's a little bit cleaner to me, but you don't have to do that. And we're on to the quadratic. You see, this cubic's gone, now we're at the quadratic. And we just repeat. Easy. How many x's in 7x squared? Plus 7x. There we go, quadratic. Tick. 7x times this whole thing, 7x squared plus 14x. Tick. Do a subtraction, 7x squared minus 7x squared is 0x squared, which is why we've achieved what we set out to achieve. Negative x minus 14x is negative 15x, and then I bring that guy down, negative 30. Tick. Now we're on to our linear term. Linear term, how many x's in negative 15x? Negative 15. Tick. Negative 15 times that linear term is negative 15x, negative 15 times 2 is negative 30. Tick. Do a subtraction, 0x minus 0, tick, and you notice here that is our remainder, which is 0. We expected because we knew that this worked. And we get now our p of x, which I won't write out, but I could, is equal to d of x, x plus 2, times by our quotient, 2x squared plus 7x minus 15 from above, and this is what we got in the last video using the other method. X plus 2, and then 2x minus 3, and x plus 5. Done. Polynomial long division can help you to factorise as well. So it's a method, but as I say, it's not technically in your syllabus, so you don't technically need to know it. We won't be asking you that here in our assessment, but it could pop up on some resources, so it might be something you want to learn. It's this process repeated over and over again. In the next video I'm going to show you an example, final one, where there is a remainder. We'll have a chat about the remainder theorem. Get on it.